Hello guys, how are you? This question says write the mathematical relation and the equivalent to the slope or the gradient for each of the following. Okay, since they want the gradient in each case, let me remind you first that the gradient is actually the change of y over the change of x. Okay, for any graph. So I'm going to apply this idea in each case. We start with part A. We notice that the y is charge and the x is time. So the gradient is the change of y, it is the q, and the x is the time. We know from before that q over time, or charge over time, is actually the electric current. So basically here the gradient represents the electric current in a circuit. Okay, so the relation is q over t and the equivalent is I. Now let's go to part B. In part B, the y is the potential difference and the x is actually the current. So gradient is y over x, it is v over I. Potential difference over current, we know from before, it is the resistance. Okay, so the relation is v over I and the equivalent is resistance. So the gradient here represents resistance. Okay, in part C, the y is actually the work and the x is the charge. So let's find the gradient. Gradient is y over x, it is work over charge, and we know from before work over charge is actually the potential difference. Okay, V, voltage, or the potential difference. So the relation is W over Q and the equivalent is potential difference. So G is V, which is potential difference. Okay, now let's go to part D. In part D, notice that the Y is resistance and the X is length. So the gradient is actually R over L. Okay, let's see what does that represents. I don't know if I have the space here. Let me go down. I will go down here. So G, this is part D, right? Yeah, this is part D. Okay, so gradient is resistance over length. We know from before that the resistance is actually resistivity length over area. Down here I have length. I can cut the length with the length, okay, and this will give me rho over A. So the relation of the gradient is rho over A, which is the resistivity over area. So this is the gradient, rho over A in part D. Okay, in part E, let me change the color. I'll take this one. In part E, the Y is actually resistance and the X is 1 over area. Again, I'll go down. Let me go down here. So part E, we found that G equals to y over x. The y, we found it resistance, and the x, it is 1 over area. Okay, so here this is the main fraction. Resistance, I can write it as resistivity of multiple length over area, and down here I have 1 over area. Okay, so I can cut the area with the area. I still have rho L over 1, which is rho L. So the gradient in part E is actually resistivity multiple length. Okay, this is part E. Let's go to part F. In part F, the y is resistance and the x is 1 over r squared. Small r here is the, since notice here it is meter to the power -2, so the r is radius. It's radius of the wire. Let's go down. Let's go down here. Down here. So this is F. Oh, sorry. This is F. Gradient is y over x. Y is resistance and x is 1 over r squared. So let's play. I have, this is the main fraction. Resistance, I can write it as resistivity length over area. And down here I have 1 over r squared. Okay, what can I do next? This is the main fraction. Down here I have 1 over r squared. And here I have resistivity multiple length. Instead of area, I can put pi r squared. Okay? Since we all know that the cross-sectional area of the wire is actually a circle. So I can cut the r squared with the r squared. What do I still have? I still have rho L over pi over 1, which is rho L over pi. So the gradient here in part F is actually resistivity multiple length over the pi. Okay? I will solve the G, H, and I in the next video, not to make the video long. If you have any question, please leave it under the video. Make sure to subscribe to get more solutions. Okay? Have a great day.